right, what is up, yo? We are going to do 822 part 1. We're going to figure out the area of regular polygons. And really what's going to happen is we're going to end up cutting these things into triangles and then figuring out the area of the triangle and then multiplying that by how many of those triangles there are in the shape. And this gets a little bit tricky. Over the years, some kids get it no problem and they can visualize it, and other kids really struggle to visualize it. And it's just one of those things that the better you are with shapes and directions and that kind of thing, the easier you're going to find this. And the more you struggle with that, probably the more difficult it's going to be. It just hits a different part of your brain. I will say, too, I think as you get older, that part of the brain really starts to mature. A lot of this stuff is difficult for high school kids, but adults can sort of do it just automatically. I think it's kind of the same thing as like a lot of you guys when you started high school were like 5'3", and now you're like 6'3". So your brain's doing the same thing, and I think this lesson's a good example of it in a weird way. Anyway, just real quickly, like I said, we're going to end up getting the area of a triangle. I do not want that. So when we get the area of a triangle, geez, the whole thing is falling apart. It's gone so south so quickly. Why is it doing that? I guess I'll do that then. Anyway, when we're looking at this, the thing is we need the area of a triangle, which is either going to be half of base times height, or it's going to be base times height divided by 2. Man, I hope you're listening, because if you're going by the visuals only, you're really in trouble. So the bottom line is these are the exact same formula, and it doesn't matter. Sometimes I do this one, and sometimes I do this one. It just sort of depends what is easier for me to do in my head. So long story short, let's say I get a triangle that looks like this. I can say, oh, look, I'll call this the height and this the base. But think about it. If I turn my head sideways to the right, I could call this the base and this the height. It doesn't really matter. The bottom line, though, is that this is certainly not the base or the height, right? You got to get like the widest and the tallest. You can't have something like that, and that's nothing as far as we're concerned. It's neither the base nor the height, and I don't think people always recognize that. But long story short, if I want to use this formula, I'm going to say, all right, well, half of the base is 3, and 3 times 8 is 24. And that's pretty easy to do in my head, right? Like half of the base times the height. So that would get 3 times 8 and 24. Or I could go over here and say, well, the base times height is 48, and I'm going to divide that by 2, and I get 24. So I don't really care which way you do it, but it's good to know both ways. Sometimes I see this, sometimes I see this. It doesn't really matter as long as you understand that they're both the same thing. And that's going to help us figure out the other shape. So at this point, we start this. It says we developed a method to calculate the measures of the interior and exterior angles of any of the polygons. How can this be useful? Today, you need to figure out 2 ways to figure out the area of this shape. And at this point, honestly, you should probably pause the video and see if you can figure out at least 1, if not 2. So I'll pretend like you paused it, and we're back. So I would say one way I could do it is I could say, well, I know that this is going to be 6, and I know that this is going to be 6, and this is going to be 6, right? These lengths. And now if I turn my head a little bit, kind of, if this is up, and now I make my head sort of look here, you can see this is the height of a triangle and this is the base of a triangle. So what I can do is I could say, well, half of the base, half of 6 is 3, times the height is 6. 3 times 6 is 18. So the area right here is 18. And I have 1, 2, 3, 4 of them. So 18 times 4 is 72. That's certainly one way that I could do that. By the way, I'll say there's so many ways you can figure out the area here. It's ridiculous. A second way that we could do it is I could say, all right, well, look, I know the central angle is going to be 360 divided by 4, so that's 90 degrees, right? And if that's 90 degrees, I know that my exterior angle is 90 degrees, so I know that my interior angles must be 90 degrees, but it's cut in 2 right here, you can see. So this one would be 45, and this would be 45. So we have our special 45, 45 triangles, right? This is 6, this is 6. So think about it. If we remember, It's 6 times the square root of 2, right? It was 1, 1, 1 square root of 2. If you guys remember special right triangles. So 6 square root of 2, 6 square root of 2. So I'm going to say 6 times the square root of 2 times 6 times the square root of 2. I get 36 times 2. I get 72. And so we get the same area either way. It doesn't matter. I will tell you, the first way I did it was actually very simple, I think, but usually this method is easier, and this is kind of what I want to focus on. First, I'm going to ask you, this is the plan that we're going to use. You're going to get the interior, exterior, and central angles, because again, we're going to probably end up using some trig here. Then what you're going to do is you are going to mark up the big triangle. Say as much of it as you can, right? Mark up one of these big triangles. Then what you're going to do is you're going to cut it into 90-degree angles. I'm sorry, 90-degree triangles. And then we're going to calculate the area of the triangle, and then use that to get the area of the larger polygon. I know this is difficult to read, and don't worry about it. I'll sort of talk through this as we go. So as I look at this one, again, I'm gonna use the interior, exterior, central angles. So I know this is 1, 2, 3, 4, 5, 6 sides. So 360 divided by 6, right, is going to be 60 degrees. And I know that my exterior angle is also 60 degrees, which means my interior angle is 120 degrees. But be careful there, because we're talking about this whole thing as 120. Half of it's here and half of it's here, so it's 60, 60, 60, if that makes sense. So we're going to go here, and I know that this is 60. So think about what I have here. I now have this bigger triangle that I'm just going to sort of move this over here. I like to sort of make it bigger and give myself a little bit of space. I'm going to mark up this bigger triangle. If this is 60 and this is 60, well, this must be 60. If this is 8, this must be 8, and this must be 8, right? Now I'm going to cut into this 90-degree triangle. I'm going to cut into this big triangle, and make it a 90-degree triangle, so I can get my base times my height. Well, think about it. This is still 60. I cut this 60 in half, so now this is 30. I cut this 8 in half, so now this is 4. At this point, hopefully we remember that we have special right triangles, right? That we can say it's as easy as 1, 2, square root of 3. Now, the thing is, I don't care at all about this. This doesn't do anything for me. I need the base and I need the height. I don't need the hypotenuse. Again, the only reason I would even want the hypotenuse is if it helped me get the base and the height, because that's all I really care about. By the way, on this one, if you didn't remember 30, 60, 90 triangle, we would use trig. I don't quite want to introduce trig quite yet. There's so much going on already. I'm just going to go with those special right triangles and we'll go from there. So anyways, this triangle, now this is where it gets a little bit tricky, how you want to visualize this, because we either have this big triangle here where it's 8 by 4 square root of 3, or we have this little triangle which is half of it, right? I don't care which way you look at it, but it is important that you know which way you're looking at it, because if I want to do it this way, it's half a base, which is 2, right? Half of 4 is 2, times the height, 4 square root of 3. So the area of this little shape, this little triangle, is 8 times the square root of 3. I'll worry about the square root of 3 later. I can grab a calculator and worry about that. But for now, that's going to be the area, right? 2 times 4 times square root of 3, we get 8 square root of 3. Over here, this bigger triangle, well, I know that half of 8, that now my whole base is 8 here, because I'm looking at the whole triangle. There's 2 4s. So it would be 4 times the square root of 3. So the area over here is 16 times the square root of 3. So again, if you're looking at the whole big triangle, it's twice as big as if you're looking at half of it, which makes a lot of sense. But here's where this gets important. We have either calculated half of one of these big triangles, and if that's the case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those that we need to multiply by and get 96 times the square root of 3. Or if we didn't, if we use the big shape, by the way, that didn't go the way I wanted, because if I erase this now, I'm going to erase this, which I don't want to, but that's fine. So times 12, which is 96 times the square root of 3. Or we have this big shape, which is 16 times the square root of 3, but there's only 1, 2, 3, 4, 5, 6 of the big triangles. So I need to multiply this by 6, and I get 96 times the square root of 3. Again, we're talking about the area of the whole hexagon. So if you're going to work with the small one, that's fine. You just need to multiply by how many triangles there are. If you work with the big triangle, that's fine. You just need to multiply by how many big triangles there are. So just be real careful on that. Now I can introduce my calculator. Obviously, it's 96 times the square root of 3 either way, so it doesn't really matter. And I get an area of 166.28. I rounded, it's 0.27, whatever. It's going to go on forever. But that is going to be the area of this. It's going to be units squared. I hope you followed this. I know this can be a lot. When we do this in the classroom, it usually takes a while to get through this. So don't feel bad if you're a little bit frustrated. Rewind the video, watch it again. See if you can kind of make that make sense and go from there. Like I said, some of you guys are going to zip right through that with no issues. Others of you guys are going to struggle. So now it says calculate the area of the 3 polygons below. So for part 1, we're going to break this lesson into two days. So we're going to do this one to end this lesson. So again, my hope would be that you actually pause the video right now and try and cut this thing up and do what we talked about and use trig, because this one you're going to need to use trig if you remember it. If not, like I said, I will definitely be going over this right now. I just think it's so much more useful if you try to learn it first, and then if you do learn it first, that's fabulous. And if you don't learn it first, at least you know kind of where you screwed up. And like I said, you learn to ride a bike by crashing a bike. You don't learn to ride a bike by watching someone else ride a bike. So make sure you guys are trying this for yourself and crashing for yourself first. So long story short, again, I'm going to do my angles first. Like we said, we're going to do our central angles and all that good stuff. So I know that I kind of mark these so I don't screw this up. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides it looks like here, right? So I'm going to go ahead and start marking my central angles and stuff like that, but I'm going to run out of space quickly. So anyways, 360 divided by 9 is 40. So I know that this is 40 degrees. This is my big triangle is 40 degrees. I know that this is 40 degrees, so I know that I have 140 degrees here, 70 here, and 70 here. So there's 70 degrees. So again, what you're looking at is this thing right over here, right? As long as we're all clear on that. Next, I couldn't see that this was 11. So I know that if this is 11, this is also 11. Now what I want to do is I want to cut this thing right down the middle, and I want to get my right triangle. So I'm going to work with my little right triangle over here. And again, I said I don't care about a hypotenuse at all. The only reason, hopefully we're all clear, this is 20, right? 40 got cut in half, and then this is 70. The only reason I care at all about a hypotenuse is I'm going to have to use trig in order to get this base and in order to get this height. And so I definitely need this. I will say this as well. Again, using trig, and I don't know how much review I need to do, and I know some of you guys added the class late, and you probably don't know trig at all, which is a bummer because it took weeks to learn. But anyway, my calculator I just put in degree mode. It doesn't matter if you go from the 70 degree angle or the 20 degree angle, you just need to be consistent. And remember, we're talking about again, just want you to see how important it is that you learn this math, because it keeps coming back and it keeps coming back and it keeps coming back. If we forget about it, we lose it, and we're in real trouble. So long story short, I'm going to start at the 70. I could have done the 20. I'm going to go to the 70. I'm going to call this the opposite, this the adjacent, and this is, of course, the hypotenuse. The hypotenuse is always across from the 90. The opposite is always across from whichever angle we're talking about. So again, if I was talking about the 20, this would be the opposite, but I'm talking about the 70, so this is the opposite. The other side can't help but be the adjacent side, but adjacent means adjacent leg, by the way. This is the hypotenuse, it's not a leg. So this is the adjacent means next to. This is the leg that it's next to. So if I want to solve for O, for the opposite, it's O over H. So I'm going to say the sine of 70 degrees equals O over 11, because I know that the H is 11. If I want to solve for the A, I'm going to say the cosine of 70 degrees is equal to A over 11. Hopefully this is all coming back to you guys now. I'm going to go to my trig chart. Maybe you have the trig chart. Hopefully I'll remember to put this online. I'm sure you can find a trig table, no problem, using the internet. Anyways, this is going to end up being the sine of 70 degrees is 0.9397 over 1 equals O over 11. Cross multiply, and O is going to equal, and again, rounding has a lot to do with this, guys, so it's totally fine if your answer isn't exactly, but it should be close. So I know that my O is 10.3. Here, my adjacent, my cosine of 70, again, make sure you're in degree mode, is 0.3420. Over 1 equals A over 11, so I will cross multiply. My A is going to equal 0.3420 times 11, and I get 3.8. And again, you know, I wrote that it was 0.3420, but I actually left it in the calculator as 0.3420201433. Here, I wrote that it was 0.9397, but I left in the calculator 0.9396926, 208. So it's not necessarily precise on all this stuff. If you grabbed the calculator and you multiplied 0.9397 by 11, you didn't get exactly 10.3 probably, and that's why we're off, because I just left the whole thing in the calculator and rounded it for this. I hope all that makes sense. So long story short, I now know the base and the height of this little triangle. I'm going to use the base times height divided by 2. I guess half. I could use 1.9, but I'm just going to go 10.3. My goodness. Why? Okay, so I'm going to go 10.3 times. I was having calculator troubles, if you're wondering why I'm groaning over here. So 10.3 times 3.8. 10.3 times 3.8 divided by 2 is equal to 39.14 divided by 2 is going to equal 19.57. I'll just call it 19.6. Don't round to like 20. Round to a tenth, but don't round to a whole number. I think you lose way too much at that point. So I know the area of this little triangle is 19.6. Well, here's the trick. I did the small triangle here, right? I did the small triangle here. And if I double that, I get the big one, and then there's 9 of them. So really I need to multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I need to multiply this by 18 to get the area of the polygon. So it's going to be 19.6, and again, I'm going to leave 19.57 in my calculator, so there's going to be some rounding going on, and that's fine, but I get about 352.2. I think about is probably the way we want to say this, units squared. So that's going to be the area of that big triangle. Again, going through the steps. Step 1, figure out your central, exterior, interior angles, get all that stuff. Step 2, turn it into a big triangle, mark that thing up. Step 3, cut it in half and turn it into a right triangle. Use your trig, get your base and your height, figure out the area of that triangle and multiply it by how many, or you could use it, again, I know that the half, like think about it over here, I already know that half of the base was 3.8, so I could have just multiplied by the height of 10.3. I could have said 3.8 times 10.3, and I would have got 39.14 is the area of this triangle, and I know there's 9 of those triangles, so I get 352.26 again, right? So it doesn't matter if you use this triangle or this triangle, but if you're going to use this one on this one, you need to multiply by 8. On this one, you need to multiply 9, and you just have to know that and keep that in track. A lot in this chapter. I hope you guys are able to follow that. Sorry it was so long, and we will pick up from there. Have a good day. Things are going south quickly here.